provided, and this is why it can be a bit tricky sometimes to show it in the equilibrium position, they're only in phase at this point if they're both traveling in the same direction. It's hard to tell at this point because this mass on the left could be traveling downwards, this mass on the right could be traveling upwards.
The wire. Because a wire is made of metal, we notice something odd about some of the electrons. They do not have to move around the nucleus and are free to move to different parts of the wire. We call these free electrons. When free electrons are given energy from, for example, a battery, they can then move through the wire to form an electric current. There's a lot of talk of collisions between particles, but that's not really what we're measuring. I can draw on this, can't I? So, firstly, if two particles hit each other, that's not really going to change the pressure experienced on this box because the box isn't part of that equation. So we're very much more concerned with the particles colliding with the side of the box itself and getting that outwards force, which is felt as pressure. You remember the force is at a maximum, so one sees at a maximum. Things that are quarter of a phase away are going to be at their minimum. So I can see a lot of you sort of zoned in on this idea of one thing being at equilibrium and the other being at its maximum. So let's draw this out. So we've got our battery, and this time we've got one bulb in loop 1, and we've got two bulbs / lamps, whatever you'd like to call them, in loop 2, and we've just confirmed that I think we're using that colour, that our battery is providing 12 volts. So if I look at this bulb 1, let's look at the bulb in loop 1. Well, that's also receiving 12 volts, and that shouldn't surprise us because we've just seen why that is, as the electrons are given 12 volts of energy. Okay, so having seen those relationships, here's a question for you. I'll get multiple choice up, so A, B, C, or D. If I've got a fixed mass, so I'm not changing the number of moles, and it's at temperature T. What happens to T if I double my pressure and half my volume? To answer that, we need to explore our third concept, voltage. To understand voltage, we must stop thinking of electrons as simply charged particles. In fact, they are charged particles that can hold different amounts of energy. I like to imagine electrons as carrying small suitcases of energy as they travel. An electron will be given this energy at the battery, which it will then carry around the entire circuit until it reaches a component that requires energy, for example, a light bulb. The electron will then give the light bulb its electrical energy, which the light bulb will transform into light and heat energy. The electron will then travel back to the battery where it will be re-energized, ready for a new lap of the circuit. Okay, so in this question, you're given a relationship for P and T, that relationship being P is equal to X plus YT. But I'm going to write it down again in a slightly different order. If I just switch the X and the YT, hopefully this reminds you a little bit of the function for a straight line graph, that being Y equals mx plus c. So let's imagine now that we've plotted that function. So we've plotted P against T, and as expected that gives us a straight line. Now for our